1 and 2. When you look at question 1 and 2, in 1 and 2, you're given A and B. In question 3, you're given A and you're given C. So you have to think, oh, in this question we know C and we know the area of A, but you're going to try and find B. So the next question is, do we subtract to get the answer? Yes. Anyone have questions on those before we continue? Okay. You're going to see that stuff again more today when we take a look at that. All right. So that was back on page 24. If you would turn towards the beginning to page 3 of your notes. Page 3. That a right triangle is a triangle with a right or a 90-degree angle. Please don't do that. The longest side of our right triangle is the side opposite the right angle, called the hypotenuse. We are going to be referring to this right out in front. If you would put equals C. And below this, please write in the longest side. So we call this side the hypotenuse of our triangle. So we're on page 3, please. The other two sides are called the legs. When we talk about our legs, the legs are adjacent, right next to that right angle. So one leg is going to be A, the other one is going to be B. So when you looked at your, if I just look back at that homework yesterday, A, B, C, A, B, C, each one of ours was labeled in that way, the legs and the hypotenuse, if we think of that, okay? So today we're going to continue with that because we're going to be exploring what is called the Pythagorean theorem. It says a right triangle is drawn below with squares drawn on each side. It says where is our right angle? So if I was asking you to show me the right angle, let's put a little square there. This would be our right angle of our triangle, right? Now in the squares, are there right angles going around at every vertice? Yes, but on our triangle, the right angle is here. Which means, if we are finding the area of each square, we're going to call this one down here A, we're going to call this side B, and we're going to call this side C. Those are my side lengths, right? It asks us to find the area. So if you were going to tell me the area of A, what's the area of square A? Just one, right? Do you agree it's one square? Okay. What is the area of B? 1 also. And here's how I want you to think about C, is if you could draw like these dotted lines, and if I put these two together, that makes what? These two together makes one square, right? If I put these two together. So what is the area of C? 2. Area of C equals 2. So it says, how are these three areas, 1, 1, and 2, related? Meaning, could we add, subtract, multiply? Is there something special about those numbers, 1, 1, and 2? Olivia, what happens if I add the smaller, the leg areas? 1 plus 1 equals what? So what we have here is the area of A plus the area of B is always going to equal the area of C. So it says, well, how long were the legs? Okay? Remember, A and B are our legs. So side A is what leg? Side A equals 1. Side B also equals 1. Can we put C under one of the legs? Has a special name called our hypotenuse, right? So that's why they ask you, what is the hypotenuse? Now, I want you to just write right below this little square thing over here. I just want you to put area is always equal to the side squared. And the side is equal to the square root of the area. Do we know the area of C?
Yes.
So if I want to find side C, that is equal to the square root of the area. Please write So what is C going to be equal to, Evan? Square root of what? What was my area? Square root of 2. Is it a perfect square? Can we find the square root? No. I'm going to leave my answer as square root 2. In this case, units or centimeters, right? That's my answer. I don't like that. I know it's not a rational number, right? That's an irrational one in our last stuff, okay? Turn to the next page. As you look at this next page, you need notes. Back over there. The green ones are way in that back, okay? Sorry about that. The drawings of the right triangles below to find the areas of all of our 3 squares, and we're going to record the numbers in the table. And we are going to kind of be careful as we look at them. And what we want to try and do is look for a pattern. So notice it says length of leg 1. That might be our A, right? Length of leg 2, that might be our B. This is going to be, we could write the area of leg 1, which how do we find the area if we know the side length? We take the side, so this is going to be side A squared. That is the area, right? That's how we find the area. Write that right above on your table. This one is going to be side B, right? Because leg 2 is B, squared, because that is our area. So this is going to be the area of the hypotenuse. This should be taking side C, right? And squaring it. So back here, if you would please write the length. We're going to add a column back here. Length of the hypotenuse, C. Now, in your notes, this next page down is this next nice picture. If you look at this first triangle, what is my side length here? 1. So this would be A, right? Do you agree? So like this is my A. A is equal to a side length of 1. What is the area of A? 1 also. This is my B. B, because this is my right angle, B has a side length of 4. Wait, oh, see that 4? That's so easy to say. People like to count the dots, but it is actually going 1, 2, 3. Because now if I look at the area, this 3 by 3 has an area of 9, right? So B, the side length is 3. The area was 3 squared, or 9. We want to fill in that table up above. When the side leg was 1, we square the side and we get area 1. Area of B was 9. We got to go count our area of C, okay? So we got to count the area of C. And here's my hint on these. It's kind of hard to draw these slanted triangles, so we drew the square for you, but I want you to draw a line coming across here. So going off from each vertex, I want you to draw that. So when you draw those lines, I now want to try and count. Inside here, I have an area of what? 4. I can already see that, right? So if I'm looking at the area of C, I already know I have 4, plus, if I take this little triangle down here, right, that's part of my square, and I flip it over and put it right here, what do these together make? Makes a rectangle that's a 1 by 3 rectangle. So what's the area of this?
1.
Wait, what's the area of this? 3. So I'm going to add 3 more, right? So that's this side flipped over. Sometimes people like to go, oh, Mrs. Thompson, I like it better if I think of sliding it up here. Does it matter? No. This would be another 3. And then these two together make another 3. So what is my area? 10. 4 plus 3 plus 3 has an area of C is going to equal 10. So on our table, we want to fill that in. Questions? Okay. Let's go down to the next one. This is put A, please. Put B. Put C. This is our right angle, correct? as I look at that first one, Julia, side A is a length of 2, and the area is 4. Ashley, Brooks, if I'm looking, side B is a length of 2. And Carter, if I'm looking at my area, or Wyatt, sorry. Area would be what? 4. Okay, so before we fill in our chart, I want you to look at picture C. And I want you to try and tell your neighbor, shoulder partner, or the person in front or behind you, if you think of dividing it this way, and maybe, like if I slid this part down here, like over here, what do you think my area of C is equal to? So tell your shoulder. So we look at those 2 legs, they filled up the hypotenuse side squared. Now if they turn that, and all the water that's in the hypotenuse area fills up the 2 legs. And I just want you to be aware that there are many ways of proving this theorem, and that was one of them. So when you take a look at that, that's kind of what we are thinking about. Area of A plus area of B equals area of C. That's what we're going to be starting our homework with. So if you would please turn back to page 25, and your homework tonight is on page 25 and 26. Okay? So 25 and 26. On page 25, you are going to start 1A with writing. Area A, it's lowercase a, because in our formula it's always lowercase with the side length. Way towards the top of this, I would like you to draw a right triangle. So back on page 24, you're going to put your right triangle. Does it matter which leg I call A or B? No. So if you want to put A on the bottom and B on the side, or you want to switch it around and put A here and B here, and then this is C. C must be always across. So on this first triangle, what do we want 5 to be? A or B? A. 12 is going to be B. We're trying to find question mark C. You're going to write down area A plus area what?
B.
Area B. Has to be equal to area C. The question asks you to find area C, right? What is the area of A? 5. This is going to be your answer, right? This is what you're asked to do. You're going to find area B. Down here, I would like you to write down side is equal to square root of area. Anytime you go to find the side length, so when we go to find side C, that's what they're asking us, the hypotenuse, you have to take the square root of whatever your area was in question 1, correct? Let's look at question 2. 24, would that be my A, B, or C from our picture at the top? 24. A, B, or C? Use B. Someone else have used A? What's the 26 going to be? Because this right angle. And if we go across, that always has to be C. That's probably the most common mistake people are going to make. So this X is actually going to be our A. So this time we are going to start, instead of writing out area A, area B, area C, you are going to start it this way. You are going to start this with putting A squared plus B squared equals C squared. What is the same as our A in this picture? X. So we're going to write X squared plus, what is my side length B? 24. You will be using your calculator because you didn't have to memorize 24 squared, right? Equals, what is side C? So this is the subtraction one also, Nick, as we were looking at from yesterday, right? So if we're going to take this on our calculator, right? We want to take, so please take out your calculator. We're going to put in 24 squared and 26. What would we do to get x squared by itself? Check it. Subtract 576 on both sides. Now you can probably do this in your head, but if not, use your calculator. And you tell me that x squared, that is the area of C, right, is equal to 100. So this is like the area of C. It equals 100. What does the side equal? Remember, side is always equal to square root of area. So in our case, square root of 100, or Fisher gives us 10. What unit do we need to use? What unit was in the problem? Centimeters, so 10 centimeters. Someplace when you do these on your paper, please circle like what that answer is, because there's a lot of work now with this, right? So circle where your answer is. So you guys have to do 1 and 2 still, if you didn't. Number 3, go around and please first put your A and B. Does it matter which one is A and which one is B? And they already gave you the C. You're going to start number 3 almost exactly how we did number 2, okay? Number 4, on the top of the next page, you got 4, 5, 6, and 7. They're asking you, find the areas of the 3 squares. So you might think of here as your right angle. This is side A, this is side B, this is side C. So you need to find the area of A. Write it right below. The area of B. The area of C. You got to count the squares like we did earlier. Then it says, use the Pythagorean theorem to show that. Okay, so your homework is this page. Your